Cool. Hi, everyone. Welcome to our SkyPilot AI Infra meetup. It's great to see all of you here. Hope you have a great night tonight and hope you enjoy the events. So let's get started. Um, I'm Zhanghao, one of the co-creator of SkyPilot, and also have Kevin here with me today. And also thanks Chloe for co-hosting this event with us. And in this talk, we'll cover three things. What the AI compute landscape looks like right now, how the open source AI infra like SkyPilot helps team navigate it, and also what's new in SkyPilot. So before we get into SkyPilot, let's look at what's happening in the AI compute landscape right now. This is the semi-analysis cluster MAC leaderboard. A few years ago, there are only, for example, 3 or 4 places you can get GPUs, such as AWS or Azure or GCP. But today, there are dozens of providers, all competing on price, availability, and class performance and quality. With all these GPU vendors, let's look at how teams are responding to these changes. So with the fast-moving AI compute landscape, more and more teams are spreading their AI compute across multiple providers. In a single year, Meta actually signed multi-billion dollars of GPU deals with both CoreWeave and Nebius, moving beyond a single cloud. Why? 3 reasons come up again and again. First of all, increasing the GPU capacity. Second, reducing the cost. And third, avoiding single point of failure. Here's another quote from the Shopify's AI team. They adopt GPUs from a new cloud and GCP. This kind of intentional multi-provider strategy is becoming the norm, not the exception. We see the same pattern for frontier AI labs and enterprises alike, from companies training foundation models to teams bringing AI. Thank you. Bringing AI into production. But there's an obvious question. If you're running across multiple providers, who's managing all of those GPU resources? Every new cloud means another console, another set of APIs, another set of failure modes. And the operational burden for managing all those compute compounds fast. AI engineers' productivity goes down by dealing with all those different AI infrastructure. That's the problem SkyPilot was built to solve. And all the logos here actually adopt SkyPilot to resolve it in their organizations. And let me show you how it happens. So SkyPilot is an open source platform that gives you a single interface for all your AI compute, regardless where it lives. Instead of managing each providers separately, your team interacts with a single system, SkyPilot. So here's how it works at a high level. You have an AI project, no matter it's a PyTorch, Ray, or whatever stack is. You tell SkyPilot what you need, say 8 B200 GPUs, and it figures out where to run it across all the AI infra fleet you own. Cloud VMs, Kubernetes, Slurm, or even bare metal on-prem nodes. The goal is simple. AI engineers get to focus on their models with the frontier level velocity, and AI infra team gets the full control with the maximized GPU capacity and utilization. So as a single platform for all your AI compute, SkyPilot gives you a single dashboard for every workloads across your organization. You can see what's running, which GPUs are being occupied, on which AI infrastructure, and who's using it. It also gives you a global view of the entire GPU inventory across every providers you own. You can see availability, utilization, and capacity at a glance. And when your team asks, do we have any H200 free, or are we utilizing our B200 as well? You no longer need to go across multiple layers or dashboards to figure that out. Last but not least, the SkyPilot system is an open source platform. it has the built-in support for single sign-on and RBAC. So that allows you to manage the team from day one. So that covers the platform side, but the major focus of SkyPilot is also about what it enables for individual AI engineers in the team. The ability to move through the full AI lifecycle at the frontier level speed, and let me show you what it means in practice. So here's a very simple example. Every AI project starts simple. You need a GPU to experiment on. And getting one GPU shouldn't require a Jira or linear ticket and a 2-day wait. With SkyPilot, it's one command, skylaunch --GPUs B200, and SkyPilot finds the available B200s across all the infrastructures, the whole AI infrastructure fleet, and spins up the dev environment for you. That's it. So once you have the dev box up, connecting to it is also super easy. Give it a name like my dev, and you can SSH directly into the dev box. Regardless, it should be in Cloud VMs, Kubernetes, or Slurm. You can also open it in VS Code, Cursor, Jupyter, or CoreWeave Marimo. Same command, same experience every time. And once you've got the prototypes running, you're ready to scale. And SkyPilot lets you define your workloads in a declarative way, in a simple, portable YAML file. So this is a typical AI project where you have a working directory that contains the code and artifacts, the setup script that installs your dependencies, and also the run script to start your program. And SkyPilot's YAML allows you to specify all of this. But in addition to that, you can specify the resources you want. For example, 8 B200 GPUs. And also it allows you to specify the file mounts for your data buckets or your checkpoint bucket. So your user program can access those data and checkpoints through the local path. And for your AI engineers, they can simply run a single command called skylaunch project.yaml, and SkyPilot will automatically figure out the best cloud infrastructure or the cluster under the hood to provision the resources, ship the code and data, and run the job for you. And when you're ready to go even bigger than a single node job, you can scale it with a single command. You just add num node 16, and you can SkyPilot will provision a 16-node cluster with the GPUs you asked for. So for production workloads, SkyJobs launch is the command that you hands off the lifecycle of the AI job to SkyPilot. It provisions the job on your AI infrastructure like Kubernetes clusters, ship your code and data there, run the jobs, and cleans up the resources when it's done. So if a node fails mid-training, SkyPilot actually automatically recovers it by finding the replacement of the node and join it into the original cluster and resume your job. So you don't get paged at 3 a.m. and for example, a GPU failure, a node maintenance, or quota reclamation, spot preemption, SkyPilot handles the whole recovery with your hand free. And that's about the basic functionalities of SkyPilot. There are a lot of new features, designed for AI in SkyPilot we couldn't get to in this talk, but I do want to share with you some exciting new features in SkyPilot. The first thing I want to share is the SkyPilot agent skill. So we all know agents are becoming a bigger part of the AI research workflow nowadays. So we asked, what if an AI agent could manage the GPUs itself, right? So that's what SkyPilot agent skills are. They let AI agent directly interact with SkyPilot to provision GPUs, launch jobs, and scale experiments all automatically. So to actually test this, after we put out the agent skills, we connected the Kapathi's auto research with the SkyPilot agent skill. And we gave the agent some access to a pool of GPUs. So without actually explicit instructions for the agent it actually developed its own resource management strategy. It screened the research ideas on H100 and promote the promising ones to H200 for the full validation. So the takeaway here isn't just like the 9 times speed up for the original auto research, but also it's that the agent is able to figure out how to use the heterogeneous GPUs it has access to, because SkyPilot made that easy for it to access the GPUs and observe the status of those GPUs. To get the access to the SkyPilot agent skills, you can actually install it by telling your agent with this sentence, install SkyPilot agents from our GitHub repo, the open source GitHub repo, or you can go to this QR code to check out our blog for having auto research connect to SkyPilot agents. So another thing I would like to share in this talk is the Slurm support in SkyPilot. We are very excited about this because a lot of teams still run significant GPU capacity on Slurm or Slurm over Kubernetes, like CoreWeave Sunk. Until now, those clusters lived in a completely separate world. Now, SkyPilot brings it in as a first-class backend as well. So that means you can manage your Slurm clusters alongside your cloud and Kubernetes all through the same interface. Skylaunch to get a dev box, SSH to connect to resources in the Slurm cluster, job submissions where you get the same working directory isolation and auto recovery, etc. And on the management side, all your Slurm clusters now show up in the same dashboard as everything else. One view for Slurm, Kubernetes, and cloud resources, all in the same view. Now let me hand it over to Kevin, our core developer of SkyPilot, for a live demo of SkyPilot.
Cool. Thanks, Zhanghao. So let's see. Cool. So is the font size like good enough for everyone?
Yeah.
Let me close this. Is it good now? Okay, cool. Okay, so just a quick show of hands, like how many people here have used SkyPilot before? Just even like a hello world example. Okay, about 1/4 maybe. Cool. So yeah, I'm gonna spend some time to like do a hello world example first, like a basic example bare bones with SkyPilot, and then next I'm going to also like show our like latest Slurm integration, which we've been working with CoreWeave a lot for like testing stuff like that. So what I have here is on the left, I've done skycheck, which is a basic command that you would typically run at first to like check whether or not you've like set up credentials correctly, your kube config, your SSH config, things like that. So I have quite a few stuff here like AWS, Azure, CoreWeave, TCP, and I have 2 Kubernetes, I have 2 Slurm clusters. So that's what we're going to be using today. And then on the right, I have like a very simple main.py script. Think of this as like your training, offline inference, RL, etc. So let's say I've been developing locally, writing code using Cloud Code, and I want to test it on an actual GPU. So what do? So we can do Skylaunch. Let's say I want a H100. And then I want to sync my local working directory to this dev box. And let's name this thing dev. And then so what SkyPilot will do is, so this is the optimizer table. So when you say you want an H100, we will check against like all the catalogs that we maintain, along with the pricing data, and pick the one that is cheapest. So in our case, we have like a pre-provisioned Kubernetes cluster with H100 nodes on CoreWeave. So that's what we're going to pick, because we're not going to like incur extra costs, like we already have the nodes. But otherwise, like we could like fail over to say like Nebius, GCP, AWS, and so on, depending on the price. And then, so this is up now. And what you can do is like, we can do SSH dev, and then you'll be in the machine right away. So to verify, like we can quickly do like NVIDIA SML, SMI, and yeah, we have the H100 machine. And then to get to our files before, we can cd into Skywork there. Let's pip install the environment quickly. And then while waiting for this, Zhanghao mentioned we could also like use VS Code, Cursor, Jupyter Notebook, etc. And I'm gonna use Cursor because that's what I use mainly. But this will essentially give you like an editor connected to this remote machine, basically, which is super nice. Let me expand this. So in here, you can open the same folder as before. And then you can do like edits and stuff like that. Like let's say we add some print lines and then run it here. And then, yeah, so it will run. So this will make your like iteration speed like super fast, because you'll be on the machine. If something goes wrong, you can just like open up Cursor, edit it, run it again, and like keep on looping until you're done. So that is the first example. And let us move on to the second one, which is the Slurm one. So I'm going to use Claude Code for this, because why not, right? We have the skills. So like I'm less concerned about like Claude messing up things. So let's do it. So as Zhanghao mentioned, we have a SkyPilot skill, which you can invoke like this, or you could also like let Claude infer it. If you say like use SkyPilot to, let's say I want to just like check available GPUs on Slurm and Kubernetes. So if you remember, I have like 2 Kubernetes clusters, 2 Slurm clusters. And like, yeah, Claude will basically, using the skill, it knows like which commands to call. One of them is like sky GPUs list, which will give you a list of GPUs and each of the clusters that we have configured. And so here's what's available. And so for the second example, I have this like simple MinGPT DDP training example, which needs like L4DS. And we have L4DS on Slurm. So I'm gonna just ask Claude to like run train.sky.yaml on Slurm. And so it should do sky launch. Let's see. Yep, sky launch. And yeah, so it's gonna launch a job basically on Slurm using L4DS, which is like defined in the stas YAML, which I will get to in a bit. So while waiting for this, another thing I want to show you is our UI. So we've seen it before a bit on the slides. So this is the clusters page, and then we'll get to this in a bit, but I want to go to the infra page first. So the infra page basically shows you, one is like the list of Kubernetes clusters. 2 is the list of GPUs and how many are free, how many are used, and like which cluster has which GPUs. And you could also like click into each of them and like see the list of nodes and the exact breakdown basically. So this gives you basically a bird's eye view. Like as an infra person, you probably want to know like which GPUs are used, which GPUs are free, and like, yeah, do stuff based on that. So yeah, this gives you like a really nice view in a single page. And then let's see if it is running. Yeah, it is still launching. So I'll just take you to the clusters page. So if, yeah, as you can see, it's still launching here. Once it's launched, you will be able to see like the job here, and then you could also see the logs. So let's wait for that in a bit. Yep. So the status is running now. And in the meantime, we could also go through the example YAML. So as I mentioned, this is a basic MinGPT DDP example. The most important part is here. So this is because we wanted to showcase Slurm explicitly. So like we set the infra to Slurm, but with SkyPilot, it's as simple as changing this one field if you want to like switch to Kubernetes or switch to AWS or GCP. And then image ID is where you can bring your own container images. In this case, I'm bringing in a PyTorch image with a particular like CUDA version. So you could do that. And this is kind of Slurm specific. So with Slurm, like typically you have like a distributed file system. So here I'm just like caching this container image in my like NFS basically, just so that I don't need to like go to Docker Hub every time. And then I'm specifying like I want 2 nodes here. And then this is saying instead of writing the checkpoints like local disk or NFS, I want to instead write it to an S3 bucket with this name, which will be mounted at /checkpoints. And then another thing is if you have your code in GitHub or wherever, which you probably do, you could specify simply the URL of the GitHub like repo, and then we will clone it for you. And you can simply like cd into the folders that you want to run on and like pip install for the setup, and also like call like main.py or torch run or things like that. And like last thing I want to highlight is SkyPilot provides a few convenient environment variables. So for example, like a common thing you would need to do in like distributed like frameworks is like get the master address to like for the workers to connect to. So with SkyPilot, we have a list of like node IPs, very convenient. You can just like get the first row and that's like your head node. This is like common for like Ray, Vril, and like those kind of like PyTorch distributed, those kind of distributed frameworks. So we also have like basic things like number of nodes, number of GPUs per node. If you're familiar with Slurm, like Slurm also have these kind of environment variables that you can like put in your jobs. It's a very similar concept. But SkyPilot just does this for like all the clouds, not only Slurm, not only Kubernetes, all the clouds that we support. And then, so let's see. So the job should be running now, and you can click on it. You can see like the name, stuff like that. You can see the logs. And yeah, that is SkyPilot in a nutshell.
Actually, I have a few more slides.
Just hold the mic.
Sure. Um, Cool. Yeah, thanks, Kevin, for the fantastic demo. I do have a few slides. Please bear me a little bit. I know we are slightly out of time, but I would like to thank the incredible community of SkyPilot. Without all these fantastic contributors for SkyPilot, it couldn't happen as this kind of AI infra system. And we now have over 240 contributors. And including, yes, there are some AI agents you can see in the screen. And today, alongside the meetup, we're also announcing the latest SkyPilot 0.12 version. Besides the agent skills and Slurm support, let me walk you through really quickly with some exciting new features in the new version here. So first up is the SkyPilot's job group. If you're doing reinforcement learning, you know the setup is painful. You need a trainer on big GPUs, data servers on CPUs, a reply buffer, and also maybe a rollout server somewhere else. Different resource requirements are all tightly coupled in the RL framework, RL workloads. So job group in SkyPilot lets you define all of that in a single YAML file. And SkyPilot orchestrates all this different requirement across heterogeneous hardware. It enables the service discovery, handles the life cycle of the jobs, and deal with the failure recovery independently. So if you're interested in this, H Company, a French foundation model company, actually put out a blog post talking about how they use job group for running their online computer use agent, online RL for their computer use agent model through SkyPilot. And check out the blog with this QR code. And the next exciting feature is the auto-scaling worker pools for batch inference. if you're doing things like embedding backfill or large-scale evaluation, you can now create a warm pool of workers and dispatch the inference workloads to all those workers. The pool scales up and down based on demand, so you're not wasting resources on idle GPUs. But you also don't have to deal with the cold start latency when a new batch comes in. Okay, that's the major two exciting features I want to talk about in the new release, but please try it out with SkyPilot. It's open source. You can install it as a client, install it on your laptop, or you can deploy it as a centralized control plane for your team. Whether you are a single researcher who wants to get a faster way to run GPUs, or an infra team managing thousands of AI compute across multiple providers. We'd love to have you try it out. And we'll be hanging around after this. So look for the pilot hat. We have quite a few people here and come to say hi. Thank you.